Dear friends, Maths Aspirants is a community of mathematics students, research scholars, and faculty members across India, started by myself in 2017. And as you know, we used to arrange online problem solving sessions to help the students who are preparing for different competitive examinations like CSE, NET, GATE, IIT, JAM, NBHM, etc. As a part of that series, today we are having a session on basics of ring theory. Uh, it will be really helpful to those who are preparing for the forthcoming CSE or NET examination. We blessed to have Mr. Jayakumar Ravindran is with us to handle this session. Mr. Jay is currently a senior research fellow at IMSc Chennai. He did his MSc from University of Madras and qualified CSIR net with JRF and NBHM fellowships. And also, Jay has already handled 2 or 3 sessions in our platform and an active contributor to Math Aspirants community. I'm sure that his insights will be certainly helpful to catch up abstract algebra in a good manner and also to get maximum mark from that area. So I'm sure that all the participants will be certainly benefited out of this today's session. I welcome everyone to this program, and I would like to express my sincere thanks and gratitude to Mr. Jay for accepting our invitation and agreeing to handle this session. Uh, Along with his research thesis writing and other busy schedules. So once again, I welcome everyone to this event. Welcome, Jay.
Okay, thank you so much. And I'm not really new to this thing, quite a few times I already given uh, the everything, the lectures and other things. So there is certain difference today. Today I wanted to go little, but in deeper. Usually we cover in a topic very vast and wide, and include as much as problem we can. But today what we did actually little different. We are trying to go very deeper in a very basic ring theory. Okay, maybe at some point of time, this is also I had in my mind. Basics are just like that. Okay, the bunch of definition and preliminary theorems and the results. So one can just skip and go and do something. But when I encountered, especially a few days before, I got a lot of screenshots, and I could able to see the connections. Even the basics are really important. And in my research itself, at some point of time, we struggled just because of basic. The proofs and results, the proofs we written for certain results are maybe 2-3 lines. That's okay. Mostly about sort of pictures. Pictures will tell in my area. Pictures will be like a proof. Okay. But each and every pictures carry a value and seems very basic for us. But anyone who can read that, they feel like, okay, it's pretty basic. But I myself started struggling along with my guide and everyone. Uh, we have to see the basics very thoroughly. Then once the basic setup done, everything seems to be very good. Okay, we can see the clear entire picture. Okay, so today I wanted to go very basic. Like I wanted to start what is ring, then go. I believe that you know already the basics. So what is ring and other thing. Let us do step by step. Okay, for that I'm going to connect from my uh, iPad. Just give me a moment. Right. So as I said, I wanted to deal with a very basic thing, and clearly notes written. I already given to sir. It will be shared, and you see that. So ring theory. So again, the style of teaching in the traditional way is giving definitions and going through step by step, but we cannot do that because of time. What we want actually, instead of that, we straightly go to the point. Okay, I'm sure you know what is ring definition. Okay, particularly commutative ring. Okay, commutative ring and unity. So this is the first step when somebody came to, so somebody coming into the class in IMSc, we asked this, do you know the examples of commutative ring? Give me certain examples of commutative ring and go further. Do you know any examples of non-commutative but unital ring, right? So they have to see the difference. So for example, all the prototype, you fix this. For prototype, commutative, Z is a prototype. For non-commutative, Mn of F, in particular Mn of R or Mn of C. This is a particularly unital ring. Okay, particularly unital ring. These are the prototype, but understanding this is not enough. So what people did actually, they started understanding this slowly. They extract the definition and see certain rich structures, and that helps a lot. Okay, so that's what we are also going to see. So what are the rich structures we are going to see? So we know what is the definition of ring, what is the definition of commutative ring, ideals, which are I'm not going to do. Okay, so ideals, we need ideal. When I say ideal, I mean left is different. Okay, so non-commutative, interesting. For example, this has many left ideals. This has many left ideals. Also, it has a many right ideals. The matrix ring. But if you say only ideal, zero and itself, only ideal. Even it is true for M1 of F, any field. Okay, you should understand this first in order to pursue what is a commutative ring. Because after certain times, people restrict and try to understand what is integral domain. In order to understand integral domain, you have to throw many things like this. This M1 of F. Okay. So first, I'm not going to deal with what are the basic things. First, I'm going to give you certain examples. Z is an example of ring. In the finite setup, Zn is example. What is Zn? Z over Nz. And n belongs to natural number union 0. So these are the very prototypical example. When you deal with the finite, when n is not equal to 0, in fact, I can go like this. When n equal to 0, this is again z. So, so I prefer to write like this. So infinite and the finite thing. Okay. Remember that this will play a very important role in a field of fractions. Also in the primes of field, this will play. Okay. Fine. So this is a finite thing. So in order to understand a finite thing, one, if you make certain statement, even in the CSR exam, you are going through certain statement, it's about finite thing. You go through this and this. For example, Zn cross Zn. Zn cross Zm with GCD greater than 1. So these are the places you have to see. I'm giving you the idea. First, what I'm going to do if I'm in the exam, I read the question. Suppose in the ring theory, everywhere it's same. I'm not able to understand what is the theory behind that. What I will do, I will start understanding the particular thing. For example, the question is about zero divisor in the finite. It has a zero divisor, no zero divisor, and all those things. Okay, particularly. So I will start looking at this place and start working for Z2 cross Z2 like that, Z2 cross Z3. So there was one question in CSIR, Z7 cross Z7, and one particular option is triggered like that. Any, it says that any subgroup of Z7 cross Z7 of the form H cross K, where H inside Z7, K inside Z7. This is one of the CSR question. I made a mistake. I thought that okay, it is true. And a similar kind of thing appears later. Z7 cross Z11. Similar kind of thing appears later. Is it true? The same question in this setup. Okay. Very particularly, when I gave the exam, I did it in a mistake. In fact, one of the other option is saying that how many subgroups are there? So they gave, fine. Okay. So this kind of questions we have to deal in the examinations. So let's proceed step by step. Okay. What are the things we needed furthermore? So the basics of ring theory. What is ring? What is commutative ring? What is the unity? Uh, then something called I need zero devices. What is zero divisor? So now I'm going to start formally. Up to this, I'm assuming also one definition about division ring and fields. I'm assuming up to this level, you know, okay, at least the definition. All I want from you definition, okay. Division ring means it's a very nice. It's a ring. One belongs to there. It's a ring, commutative ring. It's a not commutative. It's a ring almost field without commutativity. So before that, you need to understand something called integral domain. Okay. Now I'm starting. So zero divisor. What is zero divisor? There are complicated definition. For me, the definition very simple. A comma B belongs to R. AB equal to 0 implies either A equal to 0 or B equal to 0. Then R is called. Sorry, not zero divisor. I wanted to say something else. Sorry. Give me a moment. Zero divisor. A not equal to 0 belongs to R. There exists B not equal to 0 such that AB equal to 0. So we have A not equal to 0 and we have B not equal to 0. There exists B not equal to 0. When I multiply them, I'm getting 0. That's called zero divisor. Okay. You can find a lot of examples in even M2 of R. Very simple. Lot of examples. For example, just take this. This is a non-zero. If you multiply, you'll get 0. For example, 0, right? 0. This one. And this is obviously 0. So you will get 0. So two non-zero things. That's why there are certain problems in zero divisor. We'd like to not get into the business. That's why we define something called without zero divisor. So many of the undergraduate or postgraduate, they will talk about something called a field of fractions. So let us start that question. What is a field of fraction? Then we will come to that. I will give you Z. Now, can you tell me a field where Z contains? That's the question, right? I asked this question many places. In fact, one of my senior asked me this question. I immediately said Q. And I found that most of the people, almost 90% of the people chooses Q. Then why not R? Even why not C? C is much bigger and much powerful. Why people always thinks about Q? There is some reason. Why people always thinks about Q? And why people are not really consider, or even if you say countability, why not this? If you say accountability, why not this? So there are certain reasons for that. So the reason is somewhat minimal. I should tell you what is the meaning of somewhat minimal. So Q really somewhat minimal as far as Z contained in. What does it exactly mean? The meaning is, suppose there is a copy. This symbol stands for injective. Okay, whenever we use this symbol, it stands for injective. This symbol stands for surjective. This stands for bijective. In higher mathematics, people use this. Try to learn from now itself. Okay, whenever there is a ring homomorphism from other field, some other field, and we know that Q is there, automatically Q goes inside. It doesn't matter what field. If there is a ring homomorphism, injective ring homomorphism from here to here, automatically Q goes. And this is one of the very important point. I will tell you why it is very important point, because when you're trying to define what is the characteristic of F, people done it in a different way, but we can do it in this way. Okay, you start with Z and send 1 to the 1 of F. You take any field. I'm trying to define what is the characteristic in the way. You start from, you send, and this automatically becomes ring homomorphism. This becomes a ring homomorphism. Okay. So for example, if you want to send n times 1f, ring homomorphism. And we know that in the group theoretical level, nz, which is injectively into the f. In the group theoretical level, or even, I don't want the ring theory, but in the level of group theory. Okay. So now this side and this side, remember that this ring homomorphism automatically tell you that it's also ring homomorphism. And this side and that side, we need to compare. And now this is the place I'm doing it in the reverse way. You have to study this. That's why you are studying all these things. Let us understand this. Okay. So I'm going here and there. I know that I'm going here and there because of that interconnectivity. You might have wondered at some point of time why I am reading zero divisor, not zero divisor, and all those things. Because of this. And why this? It will help you later. I will tell you, it will help you later. First, we start with what is zero divisor, right? So let us understand that in Z6, 3 into 2, we know that Z10 can be thought of 0, 1 up to n minus 1 with respect to the addition and multiplication under the modulo, the remainder. Whenever it exists, for example, in Z6, 3 into 3, 9, but you are putting remainder, right? 6 out of 9 out of 6, like very 3. So it's a 3, like that. Okay. So when I multiply this, this becomes 6 and it's 0. This is non-zero. This is non-zero, but we are getting 0 when I multiply. So two non-zero number going to give 0. And we say that this is not nice. This is not nice. Okay. What is the reason? The reason is actually, look at this polynomial. All this algebra, all this other things started, they formulated later very well, but I believe it started to understanding the polynomials. People wanted to understand the polynomials really well. So the first thing, they started looking for the solution for the polynomial, and because of they started looking for the polynomial solution, they wanted to get some control. For example, x power n equal to 0. It has only one solution in real, in everywhere, almost everywhere, right? X power n minus 1 in complex, exactly n solutions, not more than n. So people started observing. So when I say not nice, this is the problem. Look at this. When I try to solve this problem, 3 is one of the solution and 0 is also one of the solution. But look at the degree. Degree of 2x is actually 1. But it has a more than one solution. These kind of things are not allowed in certain way. It is not nice. That's why we don't like it. That's why we don't like it. So in fact, any non-integral domain or any zero divisor contains. So let's say A belongs to R and A not equal to 0, zero divisor. So AX, the degree is 1, but you can see that there is a non-zero B where AB equal to 0 as well as A into 0 is also 0. So it has at least 2 solution, which we don't like it. So that's why we say it is not nice. Understanding them from this perspective, it is really not nice. So we don't like it. So we don't like it means what we want actually. So put in the back of your head, we want this kind of thing. I don't want my polynomial to have more solution than the degree. Eventually, I want my polynomial, if I have a degree of n polynomial, I want this to be expressed in some certain way like this. X minus lambda I. Let's say alpha I. Some constant, and you can assume that is a monic, and it should be in a linear form. And when the linear form is there, we can understand much more. How can you express this in the linear form? Is it, how can I express? X minus 0 is fine. But 2, I mean 3 also root, no. Can I express this into 3? 3 also root. Certainly is possible. Now the problem comes, uniqueness. You can ask me the question, why are you obsessed with the degree? I am obsessed with the degree because there is no uniqueness. Now can you see we are just talking about everything, and that is how that integral domain started coming. Something I wanted nice, integral domain started coming, and I wanted to force some uniqueness. So UFT started coming, which is called a unique factorization domain. And even more nice, PID will come, principal ideal domain. Even more nice, ED will come. What is ED? Actually Euclidean domain. Then even more nice is actually field. So these are the hierarchy you should know from the basics, and this is why you are reading from top to bottom level. So first we start from something and we are going towards the real idea behind that. Okay, so just put this in the back of your head. All this you are studying because you wanted the solution, but the solutions are certain way. The purest among pure is solving the equation. Always remember, in algebra, even in the pure mathematics, why pure mathematics, I believe certainly it's due to the differential equation, because we wanted to solve them. It's natural. Okay, so we are in the integral domain. ID, one of the best examples of integral domain is Z, and it will be helpful in a later case. Another examples of integral domain, ZP, and I will tell you in Z10 we have beautiful thing. GCD of A comma N equal to 1 if and only if A is unit in Z10. What do we mean by unit? There exists an inverse. There exists an inverse, let's say B, such that AB equal to 1. And GCD of A comma N greater than 1 if and only if A is zero divisor. This is a result, okay? Result. Using this result, multiple question being asked in the exam in a different pattern. But I wanted to teach you something. This is very regular. Everywhere you can see. You can go through any book, you will see that. But the question what I am going to ask is different. But let us understand this result. It's like a result in the school level. For example, for a matrix, just think about it. You wanted to find the inverse of the matrix. Okay, something A is given, 3 cross 3. 3 cross 3 matrix given. You want to find the A inverse. What do you do? First, you go for the determinant. The determinant is not zero, then you will proceed, right? In real matrix or complex matrix or a rational matrix, only you will proceed if the determinant is not zero. If the moment you are getting the determinant is zero, you don't proceed. Why? Because determinant function works like a tester. It is testing whether the matrix is worth to search for the inverse or not. Because after you finding the determinant also, you have to go through a lot of things. We need to find the cofactor matrix and other things and slowly construct the adjoint matrix and multiply and see that. But lot of things will be saved if you know the determinant is not equal to 0 or not. Similarly, this function works like a determinant function for tester. Like it's testing if the GCD is 1, yeah, it is unit. If it is GCD is not 1, so it is not unit. So in Zn, only two things, unit, not unit, or one can say zero divisor. So this is what I wanted to say about this. But the question, very important question. This is a IMS interview question. Be careful. Is there a ring as all? Is there a ring as all? One, zero devices. Two, invertible. That means units. Three, non-zero divisor, non-unit. It's a neither a zero divisor, not a unit. Okay. So this is one of the IMS interview question. Better be careful. Let's do what happens here. Here we have something is either zero divisor or unit in Zn. But that is not true. Let's go for this. Z2 cross Z2. This is a finite thing. And 1 comma 0, 0 comma 1. So it contains a lot of, like in this way, you put anything on this side. Y Z2, Z10 and Zm. You put anything here. You put anything here. You will get always 0. So you can see that there are a lot of things it contains as a zero divisor. If you go even more product, this is very difficult. But here there are only two divisions, unit or zero divisor. Do we have an example even in the finite case? So you can think about it. But I'm going to give you one example and one certain ring which is so important, very, very important, which is C01. You can tell me that why not a matrix ring? Okay. So matrix ring really not commutative. So generally, like more often it is not commutative. Only it is under the level when n equal to 1, it's commutative. Otherwise, from 2 cross 2, it is not at all commutative. So even in the commutative setup, this is not that one. So let us try to analyze this one. By the way, what I wanted to say, the notes I prepared, it's a complement to the lecture. Whatever today lecture what we have, it's not the notes. I'm not just reading the notes. What I am giving, you can go, for example, what is the de Jure divisor? You can go and take look at the notes. You can see the definition. What is a division ring? You can see the definition. Some key results, you can see the key results there without proofs, of course. Okay. So it's a complement. It's a complement to each other. So let us understand this. What is this? This is set of all function from, I'm taking a function which is 0, 1, continuous to R. And one of the best way to say this, 0 and 1 and real number. So the graph, it can be like this, it can be like this, it can be like this, it can be like this. So it can be anything. So best way to understand through the graph. But let us see, can I get some sort of function like this? This says when precisely by looking at the n and a, n is fixed. By looking at the a, GCD is 1 or not. If it is 1, it is a unit. If it is not, it's not. Similarly, can I get something? Yes, you can get something. But foremost, let us understand the identity function. Identity function of 0, 1. What is that? It's just x. And you can see that ID of 0 is 0. Very important. Note it. It's very important. Okay. I will tell you why it is very important later. Okay. First, I have a function from C01. So there is a function g such that fg of x equal to 1 of x, which is 1 for everywhere. That is f of x dot g of x equal to 1. That is g of x is nothing but 1 by f of x. So this guarantees that f inverse, I mean g exist implies f is non-vanishing. F should be non-vanishing. And the reverse is also true. You know that if the function is not 0, you know that in the analysis, the inverse is also continuous, right? The inverse is also continuous. So it's true. So in order to f inverse exist, f should be non-vanishing. So that clearly implies ID is not invertible. That is not a unit. Very surprising. I'm sure that most of you never ever heard, because very such a nice function like ID is not invertible. If you change the domain, it is a problem. If your domain, underlying compact domain 0, 1, if you change the domain which has no zero domain, 0, for example, 1 and 2, it is not. It is true that it is invertible. So you can see that still the domain plays a vital role. You can see that the underlying domains plays a vital role. If your domain consists of no zero, then it is a problem. But you can also cook up a certain function which similar to identity function by translating or doing certain things. Still, it doesn't matter. But in this case, in our case, we can clearly see that the underlying domain has a power, and which is a very crucial observation. So non-vanishing is actually invertible. So we are getting, so the moment you no need to construct the invertible function to see something invertible. All you want, it is non-vanishing. So identity function is not a unit. Okay, let's understand the zero divisor. Do we have some zero divisor? Yes. For example, take this. This is a function. Take 1 by 2. The function in the first of line joining from here to here and 0. The next function is a line joining from here to here, 0. That means the first of it is 0 up to 1 by 2. You can write this function from our school level. You know that, no? How to write this function, line joining things. In line joining things, you know how to do that. Okay, is a merely a translation of this function. Okay, fine. So these two functions, let us call this is f, this is g. What is f not equal to 0 and g not equal to 0, but f dot g, that is equal to 0. You can see that if you take a point here, what is f dot g? F dot g of x is nothing but f of x into g of x. To show something is identically zero, I want to show that each and every point zero. So when I take f of x and g of x, f is positive at this points anywhere here, but g is zero. Similarly, g is positive, but f is zero. So they are zero on the complement to each other if you including 1 by 2. So that says that f and g are zero, not zero individually, but f dot g is zero, saying that it contains zero divisors. So my ring in the example which I'm talking about in the question, okay, the ring in the question is really having zero divisors, definitely invertible elements because any constant non-zero is invertible. Now looking at this guy, this is not invertible, id is not unit, also not zero divisor. Okay, what does it mean to say not zero divisor? So this id function, when I multiply by some h, that is id of x, h of x, right? And if I demanding that is zero, I wanted to prove that h of x must be zero. If h of x not zero, if I'm able to get at least one h, then I can see that, yeah, it is seemingly not true. But let us see that. So id of x and h of x equal to zero, same as saying that x into h of x is zero. Now it is a real number, x into h of x. That implies h of x equal to zero for every x belongs to open zero, closed one. Because if you exclude zero, the x is not zero. So h of x must be zero. But so that implies indirectly 1 by n 0 for every n belongs to natural number. Now limit n tends to infinity, h1 by n equal to h of limit n tends to infinity, which is h of 0. So h of 0 is actually, you can see that. What is this? This is 0. Anything is 0, right? So h of 0 is 0. So that means h is identically 0. So this identity, the particular identity function, it is not a unit. Also, it is not a zero divisor. So you cannot say what sort of function this function. So it will be interesting what sort of ideal that creates. You quotient the ideal and you study the ideal, the quotient ring, and it will be really, really interesting. What sort of ring? So it's a interesting ring, really, really interesting ring. Okay. So far what we saw in the finite level, at least in Z10, we have example. I can classify my elements into two categories, unit or not unit in Z10. But here it is not. It has a, I have given you a commutative ring with a unity. It has zero divisors. You have examples. It has a invertible element. It has a non-zero divisor, non-unit, and particular example. And I also tell you that it will be very nice if we are able to see, what is the ideal it generates and quotient to the ideals. Okay, that's for the research and other things. Fine. So far, so good. And multiple questions being asked from this place. I don't wanted to, tell you that December 2016 this question comes. June 2022 this question comes. No, I'm not that kind of guy. But this notes clearly written in this sort. Okay, fine. So far, so good. Can I continue? Can I continue? I just wanted to make sure I'm audible to you and my screen is still visible.
Yes, sir.
Okay, fine. So far we had some discussion about zero divisor. You might have got some really good comfortable with zero divisor, right? So in terms of integral domain, Z is my integral domain and Z phi is integral domain. And why people likes to study? So let us understand the ring theory from three perspectives. First, I wanted to understand general theory. So all general theory created because at some point of time you might do different. Okay. Okay, fine. After the general theory, people restrict their attention to integral domain and certain integral domains like UFD, PID, and all those. This is the second part of ring theory. The third part of ring theory, they will specifically restrict to the polynomial ring over the field. Okay, they don't care about over the ring. They don't care. Go see your Dermot and Foot book. This is how they treat. Not only Dermot and Foot book, most of the authors. I used to wonder when I was a student. At that time, nobody told me this is why. So the following thing is very important. The following theorem is so important. Result. I'm going to prove that because the technique is so important. Finite integral domain implies field. What is finite integral domain? It is a commutative ring with a unity without any divisor, without any zero divisor. I'm going to prove this because the technique is very important. I'm going to give you another question as in NBHM with a similar technique. Apparently, when you see this question, you may not see this technique is useful. But so I wanted to prove this. I wanted to use some idea. But looking at the question, you may not get the same technique. For example, I will give you the question. Question in NBHM. A is actually Mn of R, real number, n cross n matrix with property AB equal to 0 implies B equal to 0. And B also belongs to M1 of R. Prove that. Actually, I'm writing, prove that A inverse exists. But the question is, A is invertible or not? The exact question in the NBHM is a true or false of type. A inverse is exist or not. Okay. But prove that A inverse is exist in our question. When I encounter this question, I don't know the idea. I don't know the idea. I was trying, okay, why don't we go like induction? Very, very bad idea, induction. I will tell you why it's bad idea. Because n equal to 1, we are very nice and commutative setup. The moment when you go to the next level, you lose the commutativeness. All the help you get from the basis, you don't get it. That's why most of the proofs won't go in the level of induction. I'm giving real wisdom. Try to understand. I'm giving you the real idea how one should be or one can be really pro in this area. Okay. Try to observe when you read, people don't use induction most of the time when they deal with M and of C because of the problem, the lower and higher commutativity. Okay. Okay. Let's go. So now I'm going to give idea for this. I have a finite integral domain. The only difference from the field and this non-zero element has an inverse or not. Look at that. 2 has no inverse, but it's an integral domain, but not a field. So only thing whether, so I'm going to take an element from R minus 0. I'm going to define R to R, phi. This phi of x is nothing but AX. The phi of x is nothing but AX. And the definition of ring theory says that, let's say x plus y. So this is Ax plus y. Distribution says that A into x plus Ay, which is nothing but phi of x plus phi of y. So this implies phi is group homomorphism. Remember, I'm not claiming ring homomorphism. It is. but I'm not claim. I don't want to claim, in fact, because when you put 1, you get A. Most of the ring homomorphism people forces 1 goes to 1. I'm not claiming. So this is a group homomorphism. It's good enough. Group homomorphism, right? The moment it's a group homomorphism, look at the kernel. Kernel is set of all x such that phi of x equal to 0, which is set of all x such that ax equal to 0. But that is just a 0. Remember, a not equal to 0. A not equal to 0. And ax is 0 without 0 divisor says that x must be 0. That means singleton. So kernel of phi is singleton. You know, for a long time you were reading mathematics, you know that, right? The moment kernel of phi is singleton, that implies p is 1 1 or injective. Both are same. I don't really like to write like this, but yeah, I like to write like this. But surjective, that implies surjective. Why it is surjective? It is surjective because R is finite and R to R. R is finite and it goes from self map. And that implies 1 belongs to the R codomain as pre-image. That is the meaning of surjective, right? So there exists a B such that phi of B equal to 1. But that is same as saying A into B is 1, and commutativity also says that because R is commutative, BA is 1. So this implies A as inverse. That means A is unit. So every non-zero, since I have taken A as arbitrary, it's true. Try to understand. This is the technique, defining the appropriate. This technique will be useful here also. Let us understand this question, NPHM question. I have A. Now we don't have even commutativity, right? But that still works because of the group homomorphism claims. I didn't use anything. Here only I used that left inverse, right inverse because of the commutativity. Let us see how this goes. I have A such that A into B equal to 0 implies B equal to 0. Whenever I multiply A into B 0, that implies B equals 0. Prove that A inverse exists. Let's do that. I'm going to do same ring theory idea. You can do for any field, not only real number, but any field is true. But I'm going to do like that. What is this? Any matrix B. I'm going to say AB. Did you notice here? While proving group homomorphism, did I use anything apart from ring like a integral property? No. Up to this level, I didn't use anything apart from the property, what is called the division property. That what do you call the division? Um, Not division. What is that called? Distributive property. Distributive property. So this group homomorphism. This is a group homomorphism. And look at the kernel. Look at the kernel. What is the kernel? Set of all B such that phi B equal to 0, which is same as saying set of all B such that AB equal to 0. I know the property saying that whenever AB is 0, B must be 0. So that says clearly that it's singleton. So that implies Mn of R, this is injective. And you know, now use the power of rank nullity. There, the power of integral domain. Now use the power of rank nullity. It is infinite thing. I know that it is infinite. Even for n equal to 1, it's infinite. Use rank nullity. Rank nullity theorem says that n square. So this must be, phi must be surjective. And if surjective, same idea. identity is here in the codomain. It has a pre-image. So there's some B naught, such that phi B naught must be identity. And what is phi B naught? A B naught must be identity. So it has a right inverse. A has a right inverse. But you know, in the finite way, right inverse in matrix, right inverse equal to left inverse. That's actually a theorem. The theorem says that if A has an inverse, then inverse can be expressed in terms of polynomial. If A has an inverse, then it can be expressed as a polynomial, hence they are commutative. So it's always going to commute with the right and left inverse. Okay, so it's enough to show right inverse. So you see the key for this, I did not get, somebody need to teach me to define this. I did not get initially. I try to use the induction or something to see that. I'm sure that I'm not going to get if unless somebody teaches. So you have to see. I have seen bunch of questions in the NBHM, very similar fashion, especially those occurs in the end of the algebra section. So when I write the exam, it's like this. Okay, algebra analysis, topology, miscellaneous, and this applications. So algebra, they have 10 questions. Last two questions are occurs in this fashion. Whether you can able to see in terms of functions or not. Okay, this is the right place to introduce a Boolean ring. Okay, this is the right place to introduce Boolean ring. You will see that the first time it gets little hard, but when you see from the different perspective, you will get a lot of things. Okay, fine. So are we clear? Can I continue? Do you have any questions? Please ask now. Can I continue?
Yes, sir. Continue.
Okay. So for let us give some motivation. First of all, why do I want to introduce Boolean at this point of time? You will see that the way of looking Boolean from one perspective little hard, but it will help you in a certain perspective. But the moment I change into functions perspective, everything feels easy. Okay, let's do it. Take X, any set. Okay, finite or infinite. Okay, take X, any non-empty. For example, non-empty. For our purpose, non-empty. Now look at this. Some people might find the symbol hard. This is an intersection symbol, but this symbol, what is this? You union and remove the common.
Symmetric difference.
Yeah, the word is symmetric difference. What does it mean actually? You union this, remove the common. We don't like to have a common. It has some beautiful structure. Why symmetric difference needed? To avoid, in order to avoid the overcounting. So for example, I wanted to count this, right? So it will be like this. The moment A intersection B is it has no common, things are great. So somehow the symmetry difference come like the word symmetric difference justified from this formula, but I don't like this formula. It's a symmetric way of difference. But this is very nice. You union them, throw the intersection. Common. Union and throw the intersection. So with respect to this as addition, this plays like addition, intersection plays like a multiplication. This becomes a ring. And it has a very beautiful property. For example, A square. That means A into A. In our language, which is A. For every A. So A is a subset of X, okay? So A square. This is the definition of Boolean ring. A ring is said to be Boolean if A square equal to A for every A belongs to R. So this is the definition of Boolean ring. We say a ring is said to be Boolean if A square is actually A. And just this one is going to be very powerful. It has lot of properties. It has really lot of properties. For example, A plus A equal to 0, or some we write like 2A equals 0. Anyone knows little bit of module theory, they can understand Boolean ring can be considered as module over Z2. But if you don't know the module theory, still okay, because Z2 is a field. We can consider them over Z2 as a vector space. So any Boolean ring can be considered as a vector space over Z2. In fact, if any vector space has a ring structure, we can do certain things. Okay, that it's not clearly true, but you can understand from that perspective, right? So A plus A equal to 0. So yeah, this is the point. We need to be little more focused on this. This will tell you how one can see from a different perspective. Let's say I am really comfortable with addition and normal multiplication. Then I wanted to see from that perspective, and we will see that. Let's see. A plus B, the whole square, is A plus B, right? That's what anything square is same thing. But what is this? This is A square plus AB plus BA. I'm not claiming this is a commutative, that will come later, but let us understand. Sorry. But this is nothing but A plus AB plus BA plus B, which is A plus B. And you can cancel because addition is a group. So we can cancel. So AB equal to minus BA. Now set B equal to A. Set B equal to A. The moment you are setting B equal to A, what happens? A square equal to minus A square, which is A equal to minus A, which is same as saying A plus A equal to 0. Right? But this is one of the beautiful thing. A equal to minus A. Now it is giving back to this. This implies AB I can minus BA. I can treat minus BA, which is minus B is like plus P, right? That's what we say. Minus A equal to plus A. So BA. That says commutative. See, this is so important. It's giving back to each other. I started from A plus B and I got A equal to minus A, but that gives actually commutativeness. Initially, I did not have any commutativeness. I don't need to assume as a commutativity. But this giving back the commutativity, just like that. I don't have the commutativity. I came back the idea. I got that A plus A equal to 0. So that gives the commutativity. So it says that, yeah, AB equal to BA. It's a commutative, right? So it's a commutative ring. Nice, good. So this gives the idea. The A plus A equal to 0 will give you the idea that something, the ring to do with the Z2, right? The ring, something to do with the Z2. This is the objective perspective. Whatever I am doing right now, it's an objective perspective. That means the elements are very nice, but the operations are not nice. The elements are nice, but the operation is not nice. What I'm trying now, look at this. For each A element, I'm going to attach xi A. What is xi A? It is a function from x to z2 such that xi A of x is actually 1 if x belongs to A, 0 if x does not belong to A. It's called the indicator function or characteristic function, so important in the measure theory. In fact, it's called the generators of simple function, and through this only people define integration. I don't want to go into that, but let's understand in our side. For each A, there is a characteristic function. So I can think this as a bunch of characteristic functions such that A belongs to power. So here the symmetry difference, what translate to? That is a question. That I change the object. Now the objects are here subsets. Here the objects are, is the sub thing functions. What is the translation? Okay, now the question now here, what is this translates to that? So let us have this. A symmetric difference B means A union B, and I'm removing the common. A intersection B, right? I'm removing the common. So I have, what is the corresponding thing? Is it true that, can I do like this? As a set theoretically, what I'm doing, I'm unioning that and leaving the common. So the indicator function, is it true? The question. Yeah, true. It is true. Because something X is here, it must be in A or B, cannot be in the common. So if it is must be in A, it will be 1. If it is in the B, it will be 0, it will be 1. Whenever something in the common, I don't want that to enter in this set. So whenever this is a common, it will give 1, it will give 1. So 1 plus 1 is 0. We are here. 1 plus 1 is 0. We are here. So this actually translates into actual addition, but instead of domain, general domain, we have Z2. Can you see the power? Okay, so let us understand this also. Is it translated to, so A intersection B? Is it A intersection B? Okay, let us ask the question. Something is common, then that will be like here. So it's 1, it's 1. Something here not common, so 0. So for example, something in A, it will give 1, but not in B, it will give 0, ultimately 0. So I translated into normal multiplication. So right now, at this point, as a student, you can ask the question, sir, we already have a very nice object, very nice operation on this side, and we could do a lot of multiplication. Why are you translating to this? The reason, I can, instead of understanding this, so this is the indicator function, I'm going through Z2, right? Instead of going to the Z2, I'm asking, I can go and understand of general function, which is going to Z2, right? So it's a sub. Indicator functions are the special to the Z2. And in fact, it's both. You can see that it's equal. You can see that it is actually equal. Okay, on the set, if you say, I can just forget about this. Can I understand this now? If I can do for Z2, why not Z3? That is not a really translation to the indicator function, or maybe I can relate to the Boolean ring, but this gives me so good idea. Can I understand this function Zn in general, or can I understand to Zp in particular? Because Zp's are good, really good. So it opens the gate. That's why giving from one perspective to another perspective is very important. Okay, so this is for general research and motivation perspective. Let's come back to our CSIR thing. So in CSIR, this is being asked. This is being asked. So one of the questions says that Z2 cross Z2 cross Z2. Is it Boolean ring? That is a question. Is it a Boolean ring? Yes, it is a Boolean ring. Another question, if X is finite, we know that P of X is also finite. In fact, 2 power norm of X, I mean mod of X. If this is a finite, is it isomorphic to Z2 cross Z2 for some finite product? Unfortunately, due to time constraint, I'm not able to give you the answer. I'm telling this true, but it takes very long time to do it. Okay, really, really unfortunate. Okay, fine. It's true. But I'm trying to motivate you. Go through the notes, and you can go really. I mean, you can understand them well. I have given you the essentially the ideas what to do. Fine. But I want you to appreciate this thing. Understanding from one perspective will lead you to very deep ideas, but understanding from another perspective will lead you and open you another dimensions. You can use the same fundamental concept to do another dimension. Okay, fine. So far we had discussed a lot of things, but related to very, the simple things. Still, I am not yet gone through something called maximal ideal, prime ideal. That those concepts required only if we are dealing with PIDs. Okay, PIDs. Really, in PID or ED, the maximality and all those things are combined. I'm not going to do that, but I'm going to give you one of the beautiful one another beautiful example. We dealt with this thing, right? Instead of R, just throw the R. Let us go for C. Still it holds. In C also it is true. It has zero divisors. It has what do you call, not zero divisor, not unit. It has unit. But something of this sub is really interesting. Instead of doing this, what about this? Where disk is S1, which is Z, such that mod Z is 1. Symbolically, it is the unital ring. I'm sorry, it is not unital ring. It is a disk. It's the interior of the unital ring. Less than 1. Sorry. You have a disk, continuous function on the disk. I want to talk little, one of the beautiful example which occurs in the exam often in NBHM especially, and also in TFR. May not be in CSR, but I wanted to understand. Let me ask the same question before I ask. I have a Z. Can you think of a field which contains this Z? Most of the people go immediately to Q. Why they went for Q? They are gone to the Q because Q intuitively has some good property which cannot be expressible at the moment. But after a series of investigation, you can see that if Z copy to any field, then Q inside that automatically. So minimality. In other words, technically, Q is the smallest field up to isomorphism contains a Z. If there is another field contains the copy of the Z, then it contains a copy of the Q. And this is very important in order to define the characteristic. Okay. So that's why the field of fraction comes into the picture. This is a fundamental concept. What is field of fraction? One can study generally field of a ring of fraction. Field of fraction is very particular, but we can study about ring of fraction. This will give you certain idea to destroy certain beliefs. Be carefully watch what I'm going to do, because throughout our studies, we think certain ring, certain fields are superior, and that are the far superior that you cannot get more than that. Okay. Let me post one question. If you are interested in field theory, let me post a question. This is the 𝕒𝕒𝕒𝕣𝕪 question. I have a field. I will give you the field. And I will give you the finite group. It's a given, okay? Given. Can you find extension, yep, such that Galois, it's a Galois extension. Galois group of E over F isomorphic C. And this is not possible when the F is complex number. Remember that. F is complex number, it is not possible. Even F is real number, it is not possible when G is greater than 2. The moment G is 3 or more, even the real number, it is not possible. It is not possible. I'm telling you, it is not possible. So real number, it's 2. Complex number, it must be 1. The group order must be 1. So she reframes, I think she reframes the question, reframed. Set F to be Q. Set F to be Q. I mean, I will give you the rational number. Can you able to find, and also a finite group? For example, S10. Can you able to find a Galois extension? And I'm telling you, this question still open. This question is still open. Very simple question, right? Still open. Yeah. So people thinks due to this kind of questions and the finite way, they don't have a very good comfortability with a infinite thing. They think, okay, these are the only way and these are the thing. Then we are done. So this must be the object of algebra. But algebra is so rich, you can create lot of objects. The moment when I say think of some example of characteristic 5, you will think Z5, right? Other than Z5, you may not think, or maybe you can think a field extension of Z5, which is not really in our control. We couldn't able to see. So if I ask you to think of characteristic of 5 in the finite level, maybe Z5 is good enough. That's very nice, very easy to see. Maybe one can think extensions of Z5, which is not clear. Algebraically also, which is not clear. But if I ask you, can you think of infinite field which has as characteristic 5? Many people don't know. But now you can know. You will see that this concept will destroy many beliefs. If the beliefs are not formed in your way, that's really good enough, because this concept will save you to believe certain things, right? Let's see. So I have an integral domain. There exists field FR such that R is injected to FR, and this is a 1. R is contained in FR 2. Any field. When I put this, like it's a ring homomorphism, right? Any field. Ring or field homo. Implies you can extend the homomorphism. You can extend that. Technically writing, I have to write very like technically if I start writing, I have to write like this as a commutativity diagram. So this diagram commute. This is a technicality, but forget about that. You try to understand from this point of view. Whenever R contained in some ring, then FR also. It is true for integral domain, and this is the reason, and this is the sole reason I believe that in Ď food book, you go today, you see the ring theory. The first thing is all about the basic. The second thing will deal with specified integral domains. The moment you understand very well about integral domain, they will go about a polynomial ring over the field, like section 1. In the second section, it talks about polynomial rings, multivariable polynomial rings over the field. So people think, so you can ask me, what is the, so I wanted to understand the polynomials, right? That's the basic thing. Always fix in your mind. The whole ring theory is coming under understanding of, under this way, understanding of the polynomials. That's why the field theory created. Okay. I wanted to understand the polynomial. In order to understand the polynomial, the best way, because I wanted to control the degree must be, I need to feel good. So degree, the number of solutions should not exist the degree. In fact, in the ideal world, I want the number of solution, the roots, to be equal to the degree. So what are the nice thing? The nice thing is integral domain. So I consider the polynomial over integral domain, and I say that there is a way to construct this FR, which is called the field of fraction. The field of fraction from the ring, which has a very nice property. In order to think about this, I can go and think of this. So it is a matter to understand polynomial over the field instead of ring. Instead of integral domain, I can always go to the field of fraction and understand. That's why it's redundant to understand the ring, I mean integral domain. We can go and understand it here. The moment you lose the commutativity, it's more complex. So people don't do that. But there are studies, they started understanding the ring, commutative ring with unity without integral domain. But it is not really interesting as far as field theory concerned. Okay. Okay, fine. Fine. So I wanted to introduce you one good example. See, the first example is Z. Z is inside, Q. So another really good example is this, which is inside QY. The second one is called Gaussian integers. The second one is called Gaussian integers, right? So it is there. But one such example I wanted to give you is this. Set of all holomorphic. Otherwise, it's very simple. All power series with radius is less than 1. You collect all power series with the radius less than 1. But I don't like to think of that way. I wanted to think of the description way is D to C. We call holomorphic or analytic. Modern word people use as analytic. Old people use holomorphic. I don't know why. Really, I don't know why. Okay. It's a set of all holomorphic function from disk, open unit disk to C, or analytic function. This is actually a ring under addition, under multiplication, this ring. In fact, this actually inside C of, sorry, this one. The bigger ring contains non-unit, non-zero, non integral term. I mean, zero divisor, non-unit, non-zero thing. It contains unit. It contains, so it is a ring which is commutative, which has unity, but very like not having good property. Whereas this having a really good property. This having a really good property. What is the property? Let me tell you. It is actually ID. Oh, so the key theorem from complex analysis, which is going to help us, is named two way, like identity theorem. Some people call, few people call is called it's called zero theorem, like they call zero. So most of the people call identity theorem. Some people call is like a zero theorem or something like that. Okay, so it says that in the theorem from complex analysis, if a function from a domain to C, domain, okay, domain, we are very within a very good domain. So domain to C, f is identically 0 on A contain D, and A as limit point. So f is identical 0 everywhere. It's called identity theorem, as far as I know. Some other names also there, which I'm going to use. See, I have f, let's say non-zero. Now, if I multiply with some g and I'm getting identically 0, I wanted to show g must be 0. In order to show it has no zero divisor. To show no zero divisor, I wanted to take something non-zero, and I want to see that f into something is 0. That something must be identically 0. This is what I want to show, right? So the moment this is not equal to 0, there exists a belongs to D such that wall a comma r, some r greater than 0, f is not equal to 0. That means not equal to 0. Discontinuity. I'm not using anything. You can use holomorphicity, but I'm using continuity. Just continuity. There exists. It's not 0 at some point. It's not 0. So that means there is a small neighborhood where it is not 0 everywhere. So that means f of x, g of x equal to 0 for every x belongs to ball a comma 0, including a. Okay, including a. At a also not 0. This implies since f of x not equal to 0 for every x belongs to ball a comma r, gx must be 0. So that implies g is identically 0. Why? We know that the ball a comma 0, for example, a minus r by n. This is a sequence which converges to a. This is clearly a sequence. When n greater or equal to, or you can also do this. Instead of do this, you can do this. This is a sequence which converges to a, and it is there. It's a very genuine sequence. And it has a limit point. A itself a limit point. So I have a subset according to this theorem. This particular function need to agree 0 on something with a limit point. Yes, it's agree on the something with the limit point. It's agree 0. So everywhere 0. This implies f is not a 0 divisor. The moment f is not a 0 divisor, you know the O of D is integral domain. Now it is very nice to ask this question. If this is the integral domain, what is its field of action? Anyone know? So question. It is asked in the NBHM exam. So believe me, whatever I'm doing today is really actually asked one way or other way in the exam. Okay, I'm not talking anything which is irrelevant to the exam, but I'm combining. This is not my original. What is original? I'm combining the way of combining. Okay, the way of expressing only original. So I can ask this question. The question is, what its field of fraction? Now you know this is the integral domain. Anybody know? Anybody come across? Anybody come across this? If you don't know, let me know that I can tell you. No, it's not easy. I'm telling you, it's not easy unless you come most of the. I mean, in generally, probabilistically, unless somebody telling you by finding ourselves, it is not easy. In fact, believing that to be the field of fraction is hard. Okay, I will give you the hint. Okay, let us have the hint. That is the reason why I wrote this format. It's a Taylor series, right? So I can think of all holomorphic function is a center 0 with a radius 1. It's a Taylor series of center 0 of radius 1. The moment you are studying about Taylor series, what is the next thing you study in complex analysis? What kind of series?
Lawrence series.
Yeah,
Lawrence series.
that is the idea. Yes. Somebody in complex analysis seriously constructed in a very good way. So the Taylor series, then the Lawrence series. So actually, go to the internet or ChatGPT, whatever. Look at the definition of Laurent polynomials. What is a Laurent polynomial, right? You know what is Laurent polynomials, right? So Lawrence series is there. It is helping us to classify the singularities. Removal singularity is actually not a really singularity. Apparently looks like singularity, but not. So we can throw away because only we get Taylor series. Then we get finite part as a Lawrence series. In the Lawrence series, when you get final principal part, then we say it's a removable singularity. Use this idea. You collect all the function of D, which has remove pole, not essential. We don't care about removable singularity. That's not really singularity. Okay. Now collect all the functions which has a pole in D. Multiple pole also possible, multiple place, but finitely many poles. Okay. Collect all, finitely many poles. Or one can, I can say that throw that thing, look at all the function which has a pole at 0. Nowhere else. Look at all the function which has a pole at 0. Do they form a ring? The next question is a commutative ring. If I add two function as a pole at 0, the result is also pole at 0. Removal singularity also consider pole of 0. Pole of order 0. Think about it, okay? So it's very nice. In Ď book, it is given how to do that. So the field of fraction is actually of this, I mean, O of D aligns conceptually to the field of Laurent polynomial. Even seeing that is a field of Laurent polynomial is very nice because you have a bigger field which is very much having problem with the poles, but you have a lower thing which can be controlled. So you wanted to recognize this to somewhere else, all you need to deal with the holomorphic function. This is very particularly nice. And anyone who goes deep into the complex analysis, I certainly believe there is something called Weierstrass product of these meromorphic functions, which has something to do with this. So the guy Weierstrass worked on these things. Weierstrass really worked on these things. I remember that one time, one of my professor named Parthasadi Chakravarti asked not me, to my seniors, that who are the three people pioneer or reason for the complex analysis. Even if you ask for analysis, the people who is reason for rigorous analysis, I would always say the number one is Weierstrass. Today we touched certain things, right? So Weierstrass will come. The polynomials are really dense in CF01. The reason why I like to read the CF01 from the analytic perspective is all about integration. Because integration, the continuous functions are dense, and Weierstrass proves that these are the dense. So it is so interconnected. You can look at algebraically, you can look at analytically. In fact, my research area is known as von Neumann algebra. Von Neumann proved that one can define the von Neumann algebra definition through algebra without any reference of analysis. Without any reference of algebra, mostly one can define using the topology. Little bit of algebra needed, but one can see algebraically, one can see analytically. You have to take advantage of this. That's also my first paper. In my first paper also it comes like that. One is analytic way, an algebraic way, how to use the advantage. That's why seeing from different perspective itself. Please do see, go and see this. This is occurred in the exam. That's what I'm saying. This is occurred in the exam. Okay, fine. So far we done with various things. Okay, finally I wanted to give you the idea. We have a lot of rings, examples of rings. Z is the ring, Q is the ring, R is the ring, ZP, Z10, Z10 cross Z2, Z2 cross Z3, Z10 cross Z10. We have matrix ring Mn of F. When you choose F to be finite, like Mn of, this is also finite, ZP, all these things are there. So these are the examples. What math people do in mathematics, we give some example and we'll give you the idea to extend the example. Meaning thereby, you start with a ring and there is a very prominent three-way to attach. And this three-way is very important. One way, look at the polynomial ring. This is the one way. And I will tell you what are the advantages and where people deal. Another thing is that look at M1 of R. You start with a ring, you can get the matrix over that ring. Another or G. You take a group, finite or infinite, doesn't matter. It may be finite, it may be infinite, it doesn't matter. You start with that and you can go on that. So you have the three-way. The first thing, which is very beautiful, units of R is same as units of Rx. This is one of the very important. You are not getting more units. You are not getting more units. Okay. But in Mn of R, you get more units, which is not necessarily lying in the underlying. In RG also, every group element is a unit. So that's why in algebra ring theory, people decided to go with RG. The more you go, the next level subjects, for you start with the ring theory, you go in the ring theory deeply, you will understand interval domain, PID, UFD, blah blah blah. Then you go, you will understand polynomial ring over field, polynomial this, polynomial that. Finally you will understand all them up to the field theory, Galois theory. You are going to understand groups, polynomial rings. That's it. Groups and polynomial ring, the connection between the groups and polynomial rings. Finally, so this is what entire algebra up to that level. Then this Mn of R is dealt with linear algebra. Most of the linear algebra model theory, there you will deal really Mn of R. This RG you will deal in representation theory. This is also part of algebra, abstract algebra. Is there in the Demittenfoot book. You will deal substantial amount of in a way representation theory, because it encodes the idea of group in certain way, the interaction between the group and the things. Okay, so we prefer to deal with this unit. The units are not more in R of X. So let us component, I mean, I wanted to component the things we learn. Look at this. We know the characteristic is P, right? How the characteristic is defined? It is defined like that. Take a integral domain. Okay, now take the field. I'm going to define the characteristic of field. Take the field. Now send n to n of 1f. Then we know by in the ring theoretical way, if there is a ring home, this is a ring homomorphism, you can see that nz, which is inside f. Remember, this side is no zero divisor and is a sub of copy. So no zero divisor. Because field AB equal to 0, you multiply by A not equal to 0, A inverse. So me must be 0. So two things is 0. One of them is not 0, you multiply by the inverse. So every field contains no zero divisor. So that implies no zero divisor. So that implies must be Z or ZP. Only two things. It must be Z or ZP. There is no other choice. It must be Z or ZP, right? There is no other choice. So if it is ZP, copy of ZP is there. Z copy of Z is there. You know, when the copy of Z is there, Q is also there. So now the question is very simple. Characteristic 0 means Q is there. Characteristic of this is P, ZP is there. Very simple. The definition may tell you in a different thing, but it's very simple. Q is there, yeah, characteristic 0. So any field with a characteristic 0, one can think of a field extension from Q. So what really we are dealing? Extension of Q. Is it possible to classify extension of Q? So the finite extension of Q is known as, it's known as number field. It's an active research area. People are doing research, something called classical field theory is a really active research area. Then one can go for ZP. ZP, those extension. So finite extension of ZP are very nice. In fact, the algebraic closure is all classified. It's there in the book, all classified. So once that got classified, you start with ZP, you take the X, and you can see that also it's true. Second, R is ID if and only if Rx. Rx is ID if and only if R is ID, in fact. So ZP is ID. So ZP of X is ID. And if it is ID, one can have a field of fraction, no? Those field of fractions symbolically written like this. So this is an infinite. Okay, this is an infinite thing as a characteristic P. Whenever people think of characteristic P, they always think of finite. No. Or maybe at the most algebraic closure of ZP. Now this is the infinite with a characteristic of P. It has a lot of beautiful things, like people really investigate these polynomials. What happens to this polynomial? Okay, people also really investigate the polynomial like this. Sorry, they take this as a field attached with the T. People investigating this kind of polynomial. Now X is a element. Okay, X is a element. Remember that. T power P. What about this? This is a f of T. F of T equal to T power P minus X. It has a lot of things. Okay, fine. So this is what I wanted to say, whole of the thing. Even though you see that today I did not even talk about ideals, maximal ideals or prime ideal and other certain things. But even in the level of basics, so what are the things today I talk? Let us summarize from the beginning. So we start about the definition. I said that, yeah, I'm not going to deal with the definition. then we see that a lot of things, that division ring definition. I really started with a zero divisor and not zero divisor, integral domain. So two key, the techniques today, whatever I taught is very important. Okay, so we talked about the one such ring which has contains a zero divisor, invertible element means units, not zero divisor, not units. Yes, it has. There is a example. Ask yourself, can you able to find examples in finite ring? Okay, in Zetan is not possible. In Zetan, is there exist a element which is neither zero divisor and not invertible, like that? Okay, try to find it. And one, I will give you the hint. Look at the Boolean ring. Try to understand from the Boolean ring. Okay. So today also we gone through about the Boolean rings. This one question, one technique. We gone about the Boolean rings. Okay. And I told you we can understand the Boolean ring from the simple, easy addition and subtract, multiplication normal sense, which is very easy for us because we practiced a lot of time. Then that will give you the lot of openings, and I told you certain things. And the very important thing is field of fractions. In the field of fractions, we have a beautiful example, and from complex analysis point of from the help of complex analysis, this particular example is how to say, uh, works as a integral domain. And what sort of integral domain this is? I mean, what is a field of fraction? That's very interesting. It's a Laurent polynomials, collection of Laurent polynomial. One has to define the Laurent polynomial simply. Go to ChatGPT or somewhere, try to understand from there. Okay, fine. So let us finish my take here. We have 15 more minutes. We can ask question. So you,
Okay,
so
thank you.
we can stop the recording, start the discussion section. Sorry.
Okay. Okay, thank you, Jayakumar,
Yeah.
for the nice session. Dear participants, now it is the time for discussion. You can ask your queries or you can share your feedback about this session. Yes, participants, please feel free to share your feedback about the session. Or if you have anything to ask about IMSc or PhD like that, you can ask with Jay.
Yes.
Hello,
Yeah.
hello sir.
Yes, please.
Hi sir, my name is Arya. I'm studying MSc in ISET and first of all,
What
thank
I
you.
said? I said
ISET
where? Trivandrum. Okay.
Tirur, yeah. And first of all, thank you sir for this section, and you explained the things so nicely and clearly, and it's really helped me to understand the concepts. And thank you, Vinod sir, also for conducting such a session. Thank you, sir.
Thank you. Thank you.
Thank you, Arya.
What about others? You can ask me questions also regarding whatever I taught.
Yes, Fatima. If any of you would like to share a feedback or if you have any query, you can ask it now.
Okay. Today I taught very basic only, no?
Yeah.
So you can, if you have questions, some particular questions you can ask, or you can give feedbacks.
Hello, sir.
Yes.
Yes.
I'm Hiba Muhammad from IT Corrected. The session was too nice. The way you have explained everything was so informative. And thank you, sir, for this nice session.
Thank you. Thank you so much.
Yeah. Thank you, Shiva.
With someone named with, you want to talk?
See, if any of you would like to say something, you can do it now. Yes, some feedbacks are coming in the chat box.
Chat box. Yes. I saw.
Okay, as it is the
Mhm.
night time, many people have different range issues and all that.
I guess. Yeah.
That okay, dear participants, if any of you would like to share a feedback or say something, you can do it now. Otherwise, we will wind up. Jayakumar,
Yeah.
it will be better if you could say something about IMSc and the openings in there.
Okay. So, what I wanted, okay, I can say something this, okay. So let's say you wanted to do PhD and you are choosing this as a career path. Not only IMSc, in general, I will tell you from my experience. From the beginning in the MSc itself, I knew that I wanted to do algebra. I like algebra, and it's too early to decide. I also like topology. At some point of time, people taught me topology. I started liking topology. But even though my love towards algebra is really, componented, like too heavy, I decided to go with algebra. So as usual, like I am doing now, when people started doing my seniors and they are giving classes, I asked these questions. I like this. What should I do? So they told me the way. I'm also conveying the same thing. If you like particular subject, like let's say algebra, at the time IMSc has lot of algebra people. Like nearly 7 professor out of 18 are doing algebra. Like it's more than one third, right? So I prefer to join that. If you like number theory, sometimes you can do number theory. You can go to HRI. Before that, whenever you like a subject, go and see uh, the page. Like for example, open IMSc page, you can see a lot of professors and their activity. So K.N. Raghavan is recently retired from IMSc. He used to have a very good personal page and professional page. You can see that it's activities, and you can understand them. He's like a very much into algebra, nothing else. Lie algebra, in fact, particularly nothing else. Okay, so you can get lot of ideas from. You can talk to him. You can mail them. So you fix the one or two. I mean, maybe three. Uh, Institutes like number theory, IIT Bombay, HRI, those are best. For algebra, CMI, IMSc, and TFR, these things are best. Why I want you to do that? You can focus on that. I got a very good rank in CSIR. I got really good rank in NBHM, really good rank in, I think 27 or something in CSIR when I gave last exam. But I did not get a good rank in GATE. GATE is like comparatively IIT going people prefers the GATE, right? I didn't get good chance because I'm not very good at an applied. So I focused on this particular area. Even in the first time when I gave CSR exam, I have no idea what to do in other subjects. Like algebra, I have idea. Complex analysis, I have little idea, very little idea. and linear algebra, not even complex analysis. I have a linear algebra, real analysis, algebra. These three subjects helped me to clear. So you have to understand how to particularize. You have to talk yourself, understand particularize, and it is right now a very good choice. I will tell you, which is I never told anyone. Okay, I never told to anyone, because in the previous sections with the sir and other people, we never faced this kind of situation. Right now, what we are going through. So you know about ChatGPT, right? Everybody knows about ChatGPT, correct? So what ChatGPT idea is far important to understand right now. I want you to go to Twitter. If you have the Twitter account, go to Twitter. Just subscribe them. I mean, follow them. You can understand what kind of things are ChatGPT doing. You have to come up with something that ChatGPT cannot do, which is the far superior creativity that you can do in PhD. Let's say you are a very good cameraman, and can I share something which is personal, sir, which is also important in a career wise?
Of course.
Yeah. So this is my personal experience. Recently, I come across one guy who is a very good photographer. In fact, he's really good photographer, and he's supposed to marry someone I know. The moment I come to know about his photography, I was telling him that you have to do something in your photography, something which is very creative. Otherwise, this ChatGPT, other things might easily will replace you. He didn't believe that. On the spot itself, he got little bit angry over me for saying this. On the spot itself, in front of everyone, I asked my Chitti means my mother's sister. I gave my mobile, asked her to take a few photos. She took few photos. Of course, it is not as good as him. But what I did, I throw those photos in a designer, Microsoft Designer, as the Microsoft Designer to create a flyer, create an album with a title, create an album with a nature film, like 4 5 things, right? So he did it. Within like few minutes, I have everything, and I showed him, and he got a little bit of intimidated, embarrassed. And he said that, oh, I can understand now. He got still angry. He got angry over me. He got angry over ChatGPT. He got angry over all AI. But his anger is not going to help, right? Eventually he will get exceeded, right? So that's what I want you to understand. Now there is another technology which is going to come, which is much more challenging, which is called Sora. That Sora is prompt. If you use ChatGPT, if we have to give prompt, then ChatGPT will generate something. So I created all my notes. Right now, the notes I provided, no, using ChatGPT. I have a ChatGPT Plus subscription. Using that subscription, I created custom GPT. Using custom GPT, I gave all my ideas, and it created very well nice notes. Because the moment our problem is that we are studying in a dual language, right? Most of the grammatical mistake comes, and we have no idea whether that's a grammatical mistake or not. So it's created that. That's why go and subscribe this OpenAI forum. You can see ChatGPT, and you can see that right now you are in a good place where ChatGPT cannot do better things right now in mathematics. But the moment Sora comes, Sora is also OpenAI project, which is a prompt-based video created. People believe that the extreme of Sora is like that. I wanted to understand Pythagoras theorem, let's say, or I am doing mathematics, right? I don't understand things in the chemistry. So I wanted to teach someone something in the chemistry. I can give the book and the PDF, possibly the tech version of that, and ask this particular page, this particular problem, teach me. People believe that after some time, maybe a year or maybe 5 years later, Sora can produce videos like a real human. They can teach us. Like Pythagoras theorem, I ask some 5 year or 7 year, maybe 10-year-old can ask Sora to create a video where it will create artificial intelligent video for them. It will come later. According to the guy, Elon Musk, AI will climb everybody. Like AI am going to climb everybody work, but it cannot do far more creativity. But when I say far more creativity, The moment it will create something again and again, which will sharpen that thing. It's given, already given. It's a smart thing. It will sharpen, it will do certain things, but it cannot create something which is not exist. It can approach that. Right now it is limited to that. That's why you are right now in a good place. You can do PhD, or you can create something really in teaching. I don't think so ChatGPT can that close to a real teacher, where real teacher can give a certain great emotions. But it got started. All this effort got started because in the spring update, ChatGPT opened their newest model called the 4o, GPT 4o, which is available to the every free user. You can go, and its new voice capability includes emotions. So people thought that when Sora comes, it won't have a emotional. It will read like there is something called Dragon Natural Reader. It will read like the statement like, let G be the group, H be the subgroup. It will read like that. Let G $G be the group. Let $H be the subgroup. Like that it will do. Later on, people fix that. People thought that that is the case, but that is not the case. It climbs. But think about that. You can create certain thing in a certain way that will go beyond all this sentence. For example, I will give you one such a very beautiful example. Go to the internet, read about Arrow's impossibility theorem. Read about Arrow's, very easy to understand. Okay, that is the first task I'm giving. Read about Arrow's impossibility theorem. It is talking about the nature of election and the candidate, how democracy, how dictatorship interlinked with the mathematics, which is everybody can understand. The Wikipedia is well written. If you don't like to go Wikipedia, ask in ChatGPT. It will tell you very, very nicely. Okay. One more advantage, there is something called automata theory. In automata theory, people proved that mathematics is incomplete. There are two theorems. I don't know anything about that, but my friend told me that he attended talks in CMI in automata theory, which is very relevant to computer science and mathematics combination. So it says that mathematics is incomplete. So something that you can do to keep on hunt for if you think of like you are hunter, okay. But this kind of rich and eliteness is not there for the people who do the regular work. Okay, I will tell you one of the good example. That's why I asked permission to share my personal view. In our home, there is a problem with fan. Okay, a fan is under the warranty. When I call the people, they gave me regional manager number. People are not responsible. I'm not getting the complaint getting done. So they gave me a regional manager number. The regional manager talked with very politeness, with utmost politeness. What best he can do, he did it. And he make sure that I get the number of the guy who is the current right now responsible to fix this. This is a technical guy. This technical guy didn't really behave well with me. So he actually, the way the manager talked with me is very polite. You don't need to give that much polite, but very polite. But the way the technical guy talked to me, he said that, sir, we get now only the complaint is now it's like Friday. We will get Monday. And I explained him, we are in the top floor and we are facing the extreme heat of sun and we need to, I explained politely everything. But he said that I will come on Monday, I will see the problem, then I will fix on sometimes, okay? That I could see that the difference between the manager and him, it's not about the education, because the manager need to be polite. You know why? Dozens of people we can get dozens of people to be in the position. Even ChatGPT can do 12 manager thing. ChatGPT can do with a 1 or 2 supervision. But a technicality, no, it's not yet evolved. That's why you have to be more technical. Can you understand this point? You have to be more and more technical. That's why it is a right path to choose. It's not only mathematics. Any research you choose, any technical you choose, try to improve the skills. Okay. I wanted to give you the final words of one of the great admirer of mine named Mark Douglas, great trader. He said that when you define the risk and accept it, you will have the peace and outcome. That means you have to define the risk. So how well you are going through the technical day is very much important to the defining the risk. You have to define the risk in terms of time in real life. Okay, so work hard. So the final comment is, you try to utilize this kind of things. Don't say excuses. Come to this kind of class. You see, I initially, when I started this class, I told sir that I created a group which consists of 250 members, nearly around 250 members, and not even able to get 30 members for the class, which is a free class. I don't understand. It is a free class. I'm not able to get even 1%, right? 250 members, 25 members. We are like asking, I mean, maybe 10%. Let's say 10%. I'm not getting 10%. Typically 17 to 30% one can expect, but I'm not get at some point of time that free class only 3 people are there, so I eventually have to drop it. So you try to use it. Don't give excuses, because the more and more time I'm challenging you, you maybe you can ask number 2 sir. You can come and challenge me. Go to the Twitter page, X page, subscribe them and see the potential things they did. It's claiming everyone's job. Unless you are so technical, so precise, you are going to wrecked by ChatGPT or some other AI. Okay. Right now you are in the good end. On the other way, you can use this ChatGPT as a leverage. Okay. So I found that Professor Kesavan from IMSc, who is retired, who did a very good job. He was NBHM exam authority for Southern region for long time. He mailed Professor Vishwanath, who was current NBHM member, to set up the question paper and other thing, that somebody created notes for previous year question paper. So we have to change the pattern. That's why the NBHM pattern changed. So Professor Kesavan mailed very clearly, unless we change the pattern, it's very difficult to split the good people from the bad people. So they changed it. Okay. Eventually that appointed in the next, I mean, the method adopted in the next exam itself. Now, far more problem, you can take the screenshot, put it on ChatGPT, and it will tell you the answer. I heard that many people are getting the wrong answer, but remember that getting wrong answer is there. I understand. But according to me, 90% is correct. Even if you're getting the wrong answer, you know what are the things to do in order to make sure. Also, Copilot is free. Also, Llama is free. You can go through 3 of them and get the answer. You no need to wait for senior or somebody to answer some math stack exchange to see. You want the answer, put it. Take a leverage out of it. You have Llama free. Llama is not in India right now, but one can use using open VPN. Using VPN you can use. So Llama is there, Copilot is there, ChatGPT 4.0 is free. You can put it there and get the answer. At least it will give you where to go. It will give you the moment to understand, right? So that's why make it leverage. So far as we need to go to IMSc, every week I have to get 5 to 6 questions, write it down. I need to go to IMSc and discuss. Sometimes they may not know. 2-3 seniors I need to discuss, but you have a great leverage. If you wanted to understand much more about this ChatGPT, how one can use for your own perspective and other thing, I plan to conduct certain classes or something which is not going well. But you can always contact me, in the WhatsApp. I can help you with that. Okay. Thank you. Thank you so much. I took some time, but it's okay. I think it's feel worth it.
Yeah, it's okay. It's okay, Jay.
Thank you.
Okay, thank you, Jay, for this session. Let us wind up here. Thank you, everyone.
Okay.
Okay, bye.